So Airbus had this massive puzzle on its hands. They went and designed the world's biggest passenger jet, but there was one tiny problem. Its parts were so enormous you couldn't actually fly them to the factory. So how on earth did they solve a problem that just seemed to defy all logic?
I want you to put yourself in the shoes of an Airbus engineer for a second. You've just designed this incredible, world-beating airplane. The factories are fired up, ready to go. But you've got this one very fundamental problem. How do you get a wing, a single wing, like this one, to the final assembly line?
Well, the short answer is you can't. At least not by air. The thing is, the individual pieces, the wings, the fuselage sections, they were just so unbelievably big that no cargo plane in the world, not one, could carry them. This was the challenge, and honestly, the solution they came up with was nothing short of a masterpiece. Now, to really wrap your head around why this was such a huge deal, you've got to understand how Airbus builds planes in the first place. It's not all done under one roof. Nope, it's more like a continent-sized jigsaw puzzle.
I mean, just look at these numbers. Airbus is an absolute manufacturing machine, pumping out over 1,000 planes a year. That works out to about 3 brand new airplanes rolling off the line every single day. And here's the kicker. The parts come from all over Europe. You've got wings being built in the UK, the tail in Germany, the nose in France, and all of these giant pieces have to somehow make their way to the final assembly line down in Toulouse.
Back in the day, Airbus used to rely on trucks and ships, but man, that took months. It was just too slow. To really ramp things up, they needed something new, something faster. So, back in 1994, they took a look at the natural world for a bit of inspiration.
And this is what they came up with. Meet the Airbus Beluga. Yeah, it's named after that distinctive-looking whale, and you can see why. It's got to be one of the weirdest-looking planes you will ever lay eyes on. But its whole purpose in life is to be a flying truck for airplane parts. That entire nose cone hinges open like a massive garage door, so they can just slide entire wings right inside. Incredible!
And the scale of this thing is just mind-boggling. The Beluga is longer than an Olympic swimming pool and as tall as a 7-story building. But the number that really mattered was this. It took a transport time that used to be measured in months and cut it down to just 2 hours. That's not an improvement, that's a revolution.
For years, the Beluga was the perfect answer. It was a genius solution. But then in 2004, Airbus basically created a problem for itself. A plane so unbelievably massive that its own brilliant solution just wasn't big enough anymore. And that plane, of course, was the A380. This right here gets to the absolute core of the new problem. The Beluga's cargo bay is a massive 7.5 meters high, but the A380's fuselage almost a full meter taller. The wings were even wider. It was just simple geometry. The parts would not fit. Airbus had designed a plane that was too big for its own supertransporter. So you might be thinking, okay, why not just make the wings in smaller pieces? Seems simple enough. Well, the answer comes down to safety and physics. The wings take on the most stress during a flight, and they also happen to hold all the fuel. Building them as one single solid piece is absolutely critical. You do not want structural weaknesses or, even worse, fuel leaks at 35,000 feet. So with flying completely off the table, Airbus had to get seriously creative. They engineered this unbelievably complex multi-stage journey, a super convoy that would travel by sea, then by river, and finally by land. This whole logistical ballet had 3 very distinct acts. First, a pretty dangerous sea voyage. Second, some incredibly high-precision river navigation. And third, a slow, careful crawl by road, right through the French countryside.
The whole thing kicks off on a custom-built ship called a Ro-Ro, which stands for roll-on/roll-off. See, you don't need cranes, you just wheel these giant parts right on board. Then the ship sets off on a 1,600-kilometer trip through the North Sea, which is famous for its nasty storms and waves that can top 5 meters. The crew literally has to check the cargo chains every 4 hours, around the clock, just to make sure these multi-million-dollar parts don't budge an inch. After surviving the sea, the parts are carefully moved onto a river barge for the next leg. But this part of the route had a very, very solid obstacle, a historic stone bridge, way too low for the cargo to pass under. Well, most of the time anyway. So this is the Pont de Pierre Bridge, built way back in 1810. Now what's fascinating is that the water level here is controlled by the Atlantic tides, a full 60 kilometers away. Only twice a day, right at low tide, does the water level drop just enough for the barge to squeak under one very specific arch. The captain has this razor-thin window, just 3 minutes, to nail the passage. If they miss it, the entire convoy stops,
and the multi-billion-dollar A380 production line gets delayed by 12 hours. No pressure, right?
Okay, so after conquering the sea and squeezing under the bridge, the components finally reach their last mode of transport, the road. This is a 250-kilometer trek from Bordeaux to the factory in Toulouse, and it's a trip that can only make in the dead of night.
And this final leg is just an incredible feat of coordination. We're talking a 40-person team of police and engineers escorting the convoy. They're using these 50-meter-long super trucks with 96 wheels to snake through tiny village streets and impossibly tight roundabouts. And the clearance? Often just centimeters between a multi-million-euro wing and a lamppost. It's just breathtaking.
And after this truly epic journey, weeks after leaving their factories, the giant puzzle pieces finally arrive in Toulouse, all ready to become the biggest passenger plane in the world.
And believe me, the sense of scale doesn't stop once the parts arrive. It takes over 19,000 rivets just to join the main body sections together, and another 4,000 to attach the wings. All in all, from start to finish, building just one A380 takes about 9 months.
Now, what's so interesting is that after all of that incredible effort, only 251 of these super jumbos were ever made. And get this, a single airline, Emirates, bought about half of the entire production run. It really shows you just how niche the market for a plane this big turned out to be.
And what a machine this whole process created. If you packed it with all economy seats, it could carry an absolutely staggering 850 passengers.
At takeoff, it could weigh over 500,000 kilograms. To put that in perspective, that's like lifting 300 SUVs off the ground all at once. And the price tag for one of these flying giants? A cool $445 million. That's the value that was so slowly and so brilliantly navigated by sea, by river, and by road.
You know, the A380 Super Convoy was an absolute triumph of logistics and human ingenuity. It's incredible, but it also leaves us with this really fascinating question. Airbus engineered this unbelievable solution to build a revolutionary plane, but it turned out the market didn't really want it in the end. It kind of makes you wonder, what's the real measure of success in these giant engineering projects? Is it just solving the puzzle? Or is it knowing which puzzles are actually worth solving in the first place?